All right, so this topic, we're going to continue the second worksheet, but I think there was actually one question we need to go through, right? Yeah, question 10. The smoke chamber kind of thing. Eugene is here. Eugene is on trial lesson. Okay, right. Let me go to the worksheet now. So last week we plotted the graph, right? Okay, we plotted the graph. Okay, I think we stop here. And then we also look at the accuracy of plotting graph. And I shared with you it's important, okay, that you plot the graph well because it can determine whether you get full marks or you get no marks. Hold on. I need to open up this page, then I can see everyone. Okay, can you see my screen? Now, the new students, you might not be able to see this question in your worksheet. Okay, this belongs to last week. Right, so we have gone through the lesson last week. I sent you the slides also. Okay, so you should have completed this if you have not. All right, and then let me see whether your answers are correct. Okay, you might want to type into the chat. We talk about the particle arrangement, right, of solid, liquid, gas. So if you were to look at arrangement of particles, okay, under this particular column, it says there's no regular pattern, but slight attraction between particles. So what would you actually put down as the state of matter?
So, solid.
Solid. Why would you choose solid?
Wait, let me think.
You think first, huh? Okay. What about Jude? What do you think? No regular pattern, slight attraction between particles.
Is it gas?
Okay, so somebody said gas, right? Jude, what do you think?
It's probably something like a gas.
You think that it's something like a gas. Anybody else has a different answer? Anyone has a different answer? Okay, Evelyn, have you done this topic in school? No, okay. Eugene is also new, right? Eugene, have you done this topic in school?
No.
No. Jinlei, what do you think, Jinlei? You were here last week? Okay, when we talk about states of matter, we are either talking about solid, liquid, or gas, right? So we can have solid, liquid, as well as gas. In primary school, you only talk about fixed shape, okay, fixed volume, right? And then you talk about all of them have mass, right? But you don't know why they have fixed shape, why they have fixed volume, or why is it that the gas, does not have a fixed shape, does not have a fixed volume. So in secondary school, we go into the arrangement of particles. We see how the particles are arranged inside each state. Then we're able to conclude, oh, that's why, okay, for example, a gas does not have a fixed shape, does not have a fixed volume. So last week, we went through all this, actually. Okay, so if you cannot remember, quickly look through the notes that I have given you. Okay, quickly look through the notes I've given you. I sent you the flipbook, right? And then you downloaded the PDF. Okay, Gazi, any clue here? So I have Zixuan saying that it is likely to be gas. Jude also says that it is gas. What do you think?
I think it's also gas because no regular pattern and slight attraction.
You saw, okay, no regular pattern is actually for both gas as well as liquid, right? Okay, what about the slight attraction?
I'm not sure.
That one you're not sure, okay? Unluck, how about you, Unluck?
Now I think something like liquid because it's not like liquids flying everywhere.
It's not like it's flying everywhere, but we are not talking about the motion yet.
No, I mean the state of matter is liquid.
Uh-huh.
I mean like the slight attraction between particles. Because I don't think like if there's no attraction between particles and then it's gonna just be like flying, you know.
I see. So your concept is it should be liquid, cannot be gas. Because the gas particles are free to move around, right? So you think that actually there's no forces of attraction between gas particles? Is that right? How about Chloe? What's your choice? Gas or liquid? You know why I'm asking or not? Yeah, because I want to see what you're thinking and why I want to see whether any of you have any misconception. Okay, so I have different answers here. Okay, so Chloe, decide now. If let's say this is your test, you will write down liquid. How about Kiran? Liquid as well? That's what you will decide on. So some of you say liquid, some of you say gas, right? Okay. Actually, all right, this is honestly the answer in the portal says that we put this as liquid, right? And then we put this as solid. Why solid? Because vibrate about fixed position. Okay, for these solid particles, they are held in fixed position. They can only vibrate. That is why, okay, that is why solids cannot be compressed. Solid has a fixed shape, fixed volume. Because of the particle arrangement, which looks something like this. Do you still recall? Okay, we did last lesson, right? So if you take a look, all right, the particles are arranged so packed, so tightly together in fixed position. Okay, you can't compress it anymore. No space to even compress the particles to come closer together. Okay, so if you are going to talk about motion now, honestly, if you have read the notes, you will know, okay, this is actually strong attraction. There must be certain error over here. Okay, whereas for the gas particles, right, Gazi, you thought that this is gas, right? Yeah, because gas particles, we say that there's negligible attraction, isn't it? The forces of attraction are so weak, it can be considered negligible. Last week, we mentioned this. Okay, so it is so weak, very slight. But if you were to refer to the attraction between the liquid particles, it's still strong. For the solids, all right, this one, they are actually a regular pattern. Very close together. Okay, and then I will also add in very strong attraction between particles. Okay, so there's a difference here, very strong, and this is just strong. For gas particles, it is weak or negligible. Negligible is spelled like this. Okay. All right, that's for the gas. So if you talk about the motion of liquid particles, how would you describe it? They can't fly all over, right? They don't vibrate about fixed position, right? What do they do? Okay. So if you recall, if you look at the notes, you should see that they actually slide over one another. Remember, I gave the example, a bag of marbles. Yes or no? So when you are actually pressing that bag of marbles, you see that the marbles can move around. Okay, they will glide over each other, they slide over each other, they don't remain in fixed position. Okay, that's how you can see it. Example of liquid.
Water.
Yeah, liquid water. How about solid?
So ice.
Yeah. Okay. Yeah. All right. So this is the question 9 for last week. Okay. Question 10. We saw this experiment before. Remember, we were talking about conduction, convection, radiation. Do you recall? Zishan,
Yeah, I think.
you think? Okay, hold on.
I remember there was this question inside the inside the worksheet.
Let me look for that video for you. Okay, it's quite an interesting video. It just shows you how the air is moving. Hold on. To show convection. Okay, this should be the one.
Before we were using Monday.com, our team was drowning in work. Our days used to split between work.
This is a demonstration of convection in gas.
Okay, I'm going to show you this video. Take a look here. Okay, you saw the video? So you understand what is happening there, right? Okay, so we come back to our question. It's exactly the same. It's just that the direction is a bit different. Okay, so you have the candle. All right. When it is lit compared to when it is not. Okay, see how this thing happens. So actually there's small pieces of the ashes that drops down. Okay, so nothing moves when the candle is not lit. Okay, the smoke hardly goes into the chamber. All right, or we can call it the chimney here. And then the ashes will fall straight down. But when I have the candle lit, what happens is the air above the candle gets heated and it's going to rise. Hot air rises, remember? You learn about this also. So when the hot air rises, the colder air needs to come in and takes its place. So what happens here? Okay, as the cold air comes in, right? The smoke, which is just on top here, and some small pieces of the ashes, right? They are very light. They're going to enter, okay, enter the chimney and follow through this path. So you can even see the smoke coming out from the other chimney. So how do you write this down? Okay, very long, but you take a look. So when the candle is lit, it heats the air around it. I changed the answer in the portal. Okay, this is not exactly the same in the portal. So the air around it actually gets heated up, right? So this becomes warm air. So the warm air rises. Cooler air from the other chimney replaces the air that has moved away. So in turn, the cooler air will get heated, will rise, and cool air will replace it again. So the current of moving air is made visible by the smoke of the smoldering paper that went down the other chimney due to the convection current. That's why you